Hello students, welcome to AIMS India online classes. This is a chemist session. Here we are discussing about the chapter symbols and formulae. What are the symbols, how symbols are given for the elements, and what are formulae, how to write the formula of a compound. These are all concepts we have seen in the earlier sessions. Now in this session we are going to see practice sheet related to this chapter. That is practice sheet 2, which includes all multi-character answer type questions, comprehension paragraph, matrix matching, and statement type assertion. These are all questions we are going to see from this practice sheet too. So let us start this with the multi-character answer type questions. See the first one among those. Which of the following elements exhibit monoatomicity? What is meant by monoatomicity? First of all, let us see what does it mean atomicity. Atomicity means the number of atoms present in one molecule of an atom, one molecule of an element is called its atomicity. With a molecule of an element, if it is having only one atom, then is called monoatomic element, and that element is said to be exhibiting monoatomicity. If an element is having two atoms in its molecule, then it is said to be diatomic molecule, and that element is said to be exhibiting diatomicity. Now here they are asking about the elements which are exhibiting monoatomicity, means the elements which are having only one atom in their molecules. Generally metals are said to be having monoatomic in nature, means their molecules will be having single atom. Metals and noble gaseous elements molecules, these all are said to be monoatomic. So here if you observe among these metals, if you find calcium is a metal, copper is a metal, mercury is also metal, so these are said to be monoatomic. Whereas if you see the last one, ozone, we know ozone molecular formula is O3, means it is triatomic. So except this, remaining three are monoatomic elements. Next one. In which of the following compounds metals have same valency? Let us try to find the valencies of the elements in these compounds. See the first compound, it is said to be magnesium hydride. So based upon the number of hydrogen atoms combining with one atom of an element, its valency can be decided. If you observe this, here two hydrogen atoms they are combining with one magnesium atom. So its valency is said to be here 2 for magnesium. In the same way here, one barium atom combined with two hydrogen atoms, hence its valency is said to be 2. What about here? Calcium also in a similar way, it combined here with two hydrogen atoms, so its valency also 2. What about sodium? If you observe here, one sodium atom combined with one hydrogen atom. So valency of sodium is said to be 1. Now here these three metals are having same valency except sodium. The remaining three metals, magnesium, barium, calcium, they are having same valency too. Next, which of the following is or the Latin names of elements? So which of the following are Latin names of the elements here? See some elements names are given. Plumbum. Yes, plumbum is the Latin name of lead. So from this Latin name only for lead the symbol is given as Pb, isn't it? Next, aurum. Aurum is the Latin name of gold. So its symbol is being Au. What about this? Kalium is the Latin name of potassium. So its symbol is being K. And mercury is its common name. Its Latin name for mercury is hydrogen. So it is not a Latin name. Only these three are correct answers now. Okay. Next one. Which of the following metals exhibit variable valency? What does it mean by variable valency? An element, if it is exhibiting more than one valency, then that element is said to be variable valent element. That exhibiting valency is called variable valency, and that element is said to be variable valent element. See here, generally, sorry, metals like copper, iron, mercury, these can exhibit more than one valency. So these metals are said to be exhibiting variable valency. Okay. Next, which of the following is divalent electropositive ion, electronegative ion? Divalent means the valency 2. Electronegative ion means ion formed by the gain of electrons. So here bivalent electronegative ion means the ion formed by the gaining of two electrons. So it should carry -2 charge. Identify the ion among the given ions here which are carrying -2 charge. Those will be bivalent electronegative ions. If you observe oxide ion, its formula is O2 minus, means this oxide ion is formed by the gain of two electrons. That's why it is called bivalent electronegative ion. Next, sulfide ion. Sulfide ion formula SO4 2 minus. So it is also bivalent ion, isn't it? So it is also bivalent ion. Nitride ion. The formula of nitride ion is N3 minus. So it is not bivalent. It is called trivalent electronegative ion. What about bromide ion? Bromine. Just like fluorine and chlorine, bromine is also ready to gain one electron and forms monovalent electronegative ion. So out of these all, only these two are bivalent or divalent electronegative ions. Okay, next one. Which of the following elements can exhibit monovalent electropositive ion? So here electropositive ion means the ion formed by the loss of one electron. That is said to be monovalent electropositive ion. See here which elements can form these monovalent ions. Hydrogen can form H plus ion by loss of one electron. So this is one answer. Silver can form two ions, Ag plus and Ag plus 2. So Ag plus is monovalent electropositive ion. So silver also can form monovalent electropositive ion like Ag plus. Okay. Next, copper. Copper also can form two ions, Cu plus and Cu plus 2. So in that Cu plus is called monovalent electropositive ion. So copper also can form. What about magnesium? Magnesium can form divalent electropositive ion by the loss of two electrons. So it is not an element which can exhibit monovalent electropositive ion. Only these three are correct answers. Okay, next. Now let us see comprehension passage type questions. See first the passage. A symbol represents short form of an element's name. A symbol represents a specific element and one atom of an element. Okay. Now let us see questions based upon this. The symbols for the elements neon and silicon are respectively. What are the symbols of elements neon and silicon? We know neon symbol is Ne and silicon symbol Si. Where are these two? Here. Neon and silicon. Of course, it is also given same. So either of these two will be correct answer. Either this or that. Okay, next. The scientist who suggested a method of representing elements using the English letters. Was that? Yes, he was J.J. Berzelius. He has given certain rules to understand how to write the symbols for an element, how to give symbol for an element by using English letters. What are the rules he told? J.J. Bergelius, he told that the starting letter of an element's name can be taken as a symbol of that element. Okay, if the starting letter is already given as a symbol for some other element, then along with the first letter, second prominent letter also is taken into symbol. If there is only one letter, that will be in the uppercase, that is capital letter will be written. If there are two letters in the symbol, then first letter will be uppercase and the second letter will be lowercase. So by following these rules, we can provide symbols for any element. If any new elements are found for them, we can give the symbol like that. So in this way, the new method of representing elements by using English letters was suggested by J.J. Berzelius, which is being followed now too. Okay. Next, identify the correct symbols for the following elements respectively. See, some elements names are given here. We have to find out their symbols. See, first one, calcium. What is the symbol for calcium? Ca. So how to give a symbol? First, starting letter will be taken as its symbol. If the starting letter is already given as a symbol for some other element, then along with the starting letter, second prominent letter also is taken into its symbol from the name. Remember, it is not exactly second letter always. It may be a middle element, middle letter, but it is said to be second prominent letter. While pronouncing by giving which letter, we can remember its name easily. That letter is taken from its symbol, from its name. So in this way, for calcium, the symbol is being Ca. See, for chlorine here, starting letter is C, but C is already given as symbol for some other element, carbon. That's why second prominent letter from its name, L, is taken into its symbol. Now the symbol for chlorine is Cl. What about beryllium? Be is its symbol. Be. Now CaClBe, where it is? Here. This is correct answer. Remember that first letter should be capital letter in a symbol and the second letter should be small letter. Okay, in that way it will be correct answer. Next, let us see here matrix matching type questions. Here some elements names are given in the column 1 and their symbols are mentioned in the column 2. Try to match the elements with their symbols. See the first element, iron. Iron symbol is derived from its Latin name, that is ferrum. So from the Latin name ferrum, the symbol is derived as Fe. So the symbol for iron is Fe. What about lead? For lead also, its symbol is derived from its Latin name. The lead Latin name is plumbum. So for this, the symbol is being Pb. Okay. What about the next element? Silver. For silver also, its symbol is derived from its Latin name argentum. So if it is argentum, then the symbol is being Ag. Okay, next, the element potassium. Potassium symbol is derived from its Latin name kalium. So now the symbol is being K for potassium. Observe once the matching given here: iron, ferrum, lead, plumbum Pb, silver, argentum Ag, potassium, kalium K. Okay, that is about matching. Next, let us see one more matching. Here, some metallic compounds are mentioned in the column 1 and their formulae are given in the column 2. Try to match these also. See the first one, metal oxide. Which is metal oxide among these? See, calcium chloride, sulfur dioxide. It is oxide only, but it is non-metallic oxide because sulfur is a non-metal. See the next one, magnesium oxide. Magnesium is a metal and its oxide is here. So it is metal oxide. You can connect this. Okay, see the next one. Metal sulfide. Metal sulfide, here it is. Hydrogen sulfide, mercury sulfide. So mercury is a metal and its sulfide is here. Mercuric sulfide is HGS. Next, metal chloride. So which is metal chloride among these all? Yes, here it is. Calcium chloride. Isn't it? Next one, non-metallic oxide. Which is non-metallic oxide among these? Sulfur dioxide. Sulfur is a non-metal. So sulfur dioxide is one non-metallic oxide. And you observe nitrogen dioxide. Nitrogen is also a non-metal. So this is also non-metallic oxide. Observe once the matching. Metal oxide, magnesium oxide, metal sulfide, mercury sulfide, metal chloride, calcium chloride, non-metallic oxides, sulfur dioxide and nitrogen dioxide. Okay, that's matching. Next, statement type questions. See the first one. Statement 1. The Latin name of mercury is hydrogerum. Is it correct? Yes. The Latin name of mercury is hydrogerum. So from its Latin name hydrogerum only, the symbol Hg is given as for mercury. So mercury Latin name is hydrogerum. It is correct. See the statement 2. Shorthand representation of an element's name is called its symbol. It is also correct. Actually, it is definition of symbol, isn't it? The shorthand representation of the element's name is called its symbol. So both the statements are correct. This will be answer now. Next, one more question. Statement 1. The formula of the compound tells the elements present in a compound. Is it correct? Yes. For example, if you see the formula of calcium carbonate, if you write this formula of a compound calcium carbonate, it is CaCO3. So from the formula we can say what elements are present in the compound, isn't it? Calcium, carbon and oxygen. These elements are combined to form calcium carbonate. This information we can tell from the formula of that compound, isn't it? So it is correct statement. Next, statement 2. A pure chemical compound is homogeneous. Of course, a chemical compound is said to be homogeneous. This is also correct. Both the statements are correct. Now, which will be the correct answer now? Here it is. Okay. Next, accession region type questions. See the first one. Variable valencies are used to indicate ions with more than one valency. Yes, the elements which are exhibiting more than one valency are said to be variable valent elements. So to represent these different valencies, variable valencies are used. It is correct. See the reason, iron iron exhibits variable valency. Yes, it is also correct because iron can exhibit two valencies, Fe2 plus and Fe3 plus. It can form two ions. Sometimes it will use only two electrons and forms Fe2 plus ion. And sometimes by the loss of three electrons, iron can exhibit plus 3 charge also. It means it can form Fe3 plus ion also. Here Fe2 plus ion is called ferrous ion. Fe3 plus ion is called ferric ion. Anyhow, iron is exhibiting variable valency. So it is also correct. Correct. Both are correct. But why variable valencies are formed? It is not the correct explanation for A. Both are true, but reason is not the correct explanation for A. Next, see the assertion. The formula for hydrogen is H2. Yes, it is a molecular formula of hydrogen. Element hydrogen molecular formula is H2. What is the reason for this? H2 represents one molecule of hydrogen. So this is a shorthand representation for the molecular molecule of that substance. So it is a formula we say. Now we can say both are correct here. Assertion region both are correct, and R is the correct explanation for A. Why the formula of H2 hydrogen is taken as H2? Why? Because here H2 represents one molecule of hydrogen element. That's why we can choose A here. Both are correct, and reason is the correct explanation of assertion. Okay, that is the practice sheet related to this chapter symbols and formulae. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.